Hello friends, I am a student of generative AI and I am recording this video to document my learnings of what exercises and projects I am doing, and these videos may be helping someone watching to get an idea how the project is being performed and what are the concepts involved. So in this video I will be telling about sentiment analysis using bag of words and TF-IDF technique in machine learning using in Python, and I will be using Google Colab to perform this project. So the code I have written and actually performed this project. So uh, for telling the viewers how it is performed, I will be explaining the code more or less line by line, and whenever some explanation in detail will be required, I will be giving that explicitly. So while we'll be starting this project, uh, you can see that I have imported some of the libraries. I will be explaining what is the role of these libraries as we will be seeing the code, so that we will see the relevance of the libraries used over there. And over here we can see this is a small step, like we have imported pandas as PD. So for pandas we are setting the option of max columns and max rows for the display over here. This is more of a display setting in the layout of the what is being displayed on the screen, so it is not much about the code for technical detail. So we will be starting first, we will be mounting the Google Drive over here, so that we can import the data from that. So our data I have stored in my Google Drive in a folder called LLM, and the data name is imbd dataset.csv. This dataset will be available in the description of this video, and this code will be also available in the description in my GitHub repository. So first we are creating a pd dot data frame using pandas, and we have imported the data from the data path which we have stored in this variable. Now from the df.head we get the data what's there, first the first five rows and the corresponding columns, review and sentiment. The data is actually about the movie reviews given in IMBD, and over here we have got the reviews given um, by the reviewers, and the sentiment has been manually marked as a positive sentiment for the from the review, or the negative sentiment. Now the project we will be doing will use machine learning and the data over here to generate an algorithm that will help us predict if the sentiment is positive or negative by inputting the review into the algorithm we make. So first we will see the shape of the data. It is 50,000 rows and 2 columns, but for the sake of this project, since we are doing it for learning purpose, we are actually just taking first 10,000 columns. As you can see, the df has been taken from 0th to the 10,000th column, 10,000th row. Actually since we are keeping 10,000, it will take from 0 to 9,999. And we can see that head, it is not, it is actually the same data, but the first 4 rows it is showing the same, but actually if you see the shape, now the shape has changed to 10,000 rows and 2 columns. Now if we see the content of the review in the first row, in the first review column, so this you can see the review what has been generated or scrapped from the review website. But and now you also see that the how what are the values of the sentiment, means how many of the positive sentiments are there and negative sentiments are there. Now we see that is there any null row in the data set. As you can see, it's not there. If we see there is a duplicate data, then we will see that 17 duplicate rows are there. So we will drop the duplicates, and in place of the old data frame, now we have the data frame which has the removed rows from removed duplicate rows actually. And now if you see that if there are duplicated rows over there, then there is zero duplicated row now. So first step is complete. Now we'll do some basic pre-processing. As you can see in this data set, there are some HTML tags like this breaking line is there, break line is there. Again you can see break line tag is there. These tags are actually used in HTML. So for this we'll write a code first to remove the HTML tags, and another step we'll do is that we'll lowercase the reviews over here so that these all capital letters will become small letters. The benefit will be what the benefit will be, that is the actually when we will be feeding this to the machine learning algorithm, if we keep the capital and small letters different, then there will be an additional step, that additional more number of words which will be needed to train the algorithm, as it will consider the for instance this one with a capital letter O and one with a small letter O different. If these both if such cases of multiple words are present in the data set, then it will unnecessarily increase our data set's complication. So we need to keep things simple, and that's why we'll lower the cases. And another thing, we will remove the stop words. What are stop words? Let me tell you. Let me show you some examples over here. I have marked some, if you can see this, some English words are there like of, the, other. These kind of words don't convey the sentiment of the sentence, but are more of the used to in the grammatical sense. So if we remove these kind of words, then it will help us to perform the ML algorithm more efficiently, as complications will be reduced. And you may be knowing the concept of the curse of dimensionality, that the more number of the dimensions are there, it becomes harder for the ML algorithm to perform efficiently. So that's why the better the number of dimensions are less, it will be better. So that's why we'll remove these unnecessary grammatical words from the reviews in the data set, so that our complications are easy. But we need to take care that there are some words like not good. Suppose this is the word, and if we consider if we say that not is a stop word, then actually if someone is writing that the review is not good, movie is not good, or someone is writing that the movie is good, so not makes an important difference. So we should make sure that we don't consider not as a stop word. So I'll tell you about it, how we can do this. We'll go step by step actually. So these three steps, as I told you: HTML removal, lowercase, and stop word removal. So first we'll make a function to remove the HTML tags. Remove tags is such a function, and how it's working I'll tell you. First you need to look at this re.compile and this code. What is happening, you need to look carefully into this. This is making a regex function, that and this is actually making that function generate. Okay, let me tell you this step by step. What is this thing is doing? Re.compile. Suppose that there is a this is the same thing actually written over here. What happens is that first we'll see this left arrow, and then there is this thing, a dot and then a star. What this does in regex is that first we see any type, this dot stands for counting any type of character that is present over inside the sequence. So after this, if what this is conveying, and this star, what this star means is that the number of such characters can be repeated any number of times. So, and this question mark stands for whether this question mark will stand for it's okay if this pattern is present, and it's also okay if it is not present. So what this thing is combining as a whole, let me tell you. First there is an arrow, left arrow, then this stands for any number of characters can be there, like this p tag is there, this head is there, this h is a character, e is a character, and so on. So h can be represented by this star, as if this is a character, and then this, since actually h can be represented by this dot, and since there are any number of characters, so like this h, it can go far beyond till this another arrow which is there, till it doesn't reach the another arrow, it will count from starting of the H till the head, till the D. So this whole word will come inside this. So in this way regex is working, that first you count the any number of character, first you take into consideration any character, take into consideration any number of that kind of characters, and so in this way this head word is getting recognized by these two instructions, and these two full stop and a star. And then this question mark makes is that it's okay if such a number of characters are there, and it's also okay if they are not there. So because of this question mark, if there is a just a left arrow and a right arrow and there is no character in between also, then also it will grab this meaning. So using this function and using this command, what we are able to generate is that it will capture this p tag, a case where this p tag is there, so a head tag may be there, a br tag, as I told you in earlier example, may be there. If there is nothing inside the tag also, but this left and right arrow is there, it will capture. Similarly, it will capture any type of word which is there in between these two arrows. If there is a closing tag, suppose this kind of closing tag of a head or something like that is there, then also it will capture this. So sorry, now since we have captured this word using this function, now there is another command re.sub. It will replace this captured word by an empty string. Empty string means whenever this word is there, these kind of words are there, it will be removed by an empty string. Nothing will be there in place of that. So if there is suppose there is a p character over here, when using this command, this p character will get removed by an empty string like this. So yeah, so and this you can see that this clean text is being applied using this raw text which we got from this function input, and then it will clean the HTML tags and then return the clean text. And now this on our review column, we are applying this remove tags function to remove such HTML tags. So after removing, you can see that all the HTML tags have gone. Now similarly, we will apply a lowercase function on the review tag, so to lowercase all the characters. Then we need to, and then we from the NLTK library, it's the NLTK library is used for managing natural language processing tasks. So it provides some of the functions. From that we are using the stop words to to remove the stop words I mentioned earlier from our review column. So this is removing the stop words. What it is doing, let me explain the function. First it will apply a lambda function for the review. So lambda means inline function actually we are writing. So it will take the data in the review column instance, and then it will actually break the review column on the basis of spaces. Like this split function works on the basis of spaces, since this word is these words are separated by spaces. So actually it will and what will happen, that this array will be created. In the array we will be having the words separate, each of the word as an array element, and we will be getting that array element only in the case that the item is not there in the stop word list. So when we are splitting the function and adding that the item word as item to that array, the word will be only added in case there is the word which we are considering is not a stop word. Like if this off is there or the is there, these kind of words are stop words, so they will not be actually considered. Okay. And now when the array will be created, actually after the array has been created, the stop words have been removed, so that review will again be joined as with a space in between the array elements, and will be combined to form a sentence. So we are actually the result of this is that we are getting back the review elements, but the space, but the actually the stop words have been removed from this. So this pre-processing has been done, and now actually our pre-processing has been done. The three tasks which were there, removing HTML tags, lower casing, and removing stop words, this has been completed. And let me tell you that in the NLTK, as I mentioned earlier, words like not or no or these kind of words are not given in the stop words, given as stop words in the NLTK library. So if those kind of words are given there, then it will remain in our review, so that will help us in the forming a good ML algorithm. Now so after this we need now we have to start with our training, but before that we need to um, separate the x value and the y value. So x, so you need to see over, you need to see over here that we have actually not taken x like the, sorry, this I have run, but there is no need actually. Just a minute. This df.iloc will have taken that df will iloc df.iloc all the rows, and the only the 0th column, this is the one is written over here, that but first column, the last element will not, last column will not be considered. Sorry, actually we have not run this from the starting, that's why this kind of issues there. By mistake clicked this, so we don't need to see this for now. Okay, leave it. So x will give us the review column as a df, and we are taking it as a df, and that df not as a not in the way like y is taken, because this way it will be, y will be generated as a series, but we need to process the x as a data frame. But since this is a target value, if it's a series also, it's not a big problem. So x has been taken as a data frame, and y has been a series actually. So though both the x and y values have been separated, now we can see that we are using label encoder to actually the issue, one thing we need to see is that since the machine cannot process words or tokens as for its processing, so we need to convert it into a numerical value so that it can form the algorithm. So we are importing label encoder and converting this positive to 1 and negative to 0, so 1 and 0. So this will be easy for the ML algorithm to process. Now we are performing the train test split and using the test size as 0.2 times the whole batch, and the train will be automatically 0.8 times the whole batch. You can see the shape of the x test and a y test. Now we are performing count vectorization. Actually this is a bag of words only, but for that we need to import count vectorizer and initialize a count vectorizer object, and we will be performing train the on the train data we will be performing fit underscore transform, but on the test data we will be performing transform only, not fit underscore transform, because we don't have to fit it and then transform in the case of test data. So yeah, though both arrays are will be ready then, and we'll be using Gaussian naive Bayes algorithm to fit the data, and then prediction will be done with the test data to check the accuracy. So accuracy with for the for this for using bag of words with Gaussian naive Bayes, the accuracy we are getting as 0.63, and the confusion matrix is as you can see. Now we will be performing the same with random forest. So random forest also we will be getting the accuracy, and the accuracy has been coming as 0.84% actually. So next is we will be performing actually with n-grams. What we mean by this is that in n-grams we take it the words as like here I am specifying as the 1 and 2. I will tell you what it means. Like when we are taking n grams of 2, then the word will be considered combined, so that one of or of the these kind of these words will be combined, and then it will be used for the bag of words algorithm, and one is the default one, so like one of the, like this kind. Actually the stop words won't be considered, but I just use as an example so for explaining. So this has been done. X-ray, you can see this is it found to array. The X test has been taken out, the random forest classifier, and then you can see the accuracy score is not very different actually. Max features also I need to tell. Max features means that it will be taking a maximum of 5,000 array elements only. Like if we count the number of words which are there in the review, it will be much more, like in the count of suppose 15 to 20,000, but to avoid too much of dimensions, it will be considering the top 5,000 words. So now the prediction is being done, and then we get 0.84 for this also. We will be doing with TF-IDF. It's similar to bag of words, but has some mathematical algorithms, mathematical formula different from the bag of words, to incorporate the importance of the words in regards to the whole document as well as the whole sentence, like how much important that word is relative to the sentence, this kind of. So we get with TF-IDF we get the accuracy score of 0.85 or 85%. So here we have done with bag of words and TF-IDF. Now I will show with Word2Vec. In Word2Vec also more or less maximum things are same only. From where it is differing, let me tell from there. So this basic pre-processing will also be the same only. Just a second. More or less it is same. Let me tell from what it is differing. Yeah, so from here we actually install, and we need to write this upgrade, otherwise sometimes it gives an error, so that it uses the latest version. So gensim will be used, and gensim has a Word2Vec model where we will be using. So this window size means when it is considering suppose the word for vector conversion, if window size is 10, it will consider the 5 words around this, like 5 words around this thing, and 5 words like from here. So it will give 5 window styles of 10 means it will be considering the surrounding 10 words of it to form its vector. Okay, and min count means of 2 means the word should appear a minimum of 2 times in the whole corpus. Corpus means the whole of your document, whole of your data set. In that thing it should appear at least 2 times. Suppose one time a word is appearing, then it is not a very relevant word for forming a vector and doing the calculation. That's the idea. Okay, so over here actually we need to convert the values of the X review into an array so that it can process it better. So just let me see what's there. Okay, so over here actually before this, in the case of Word2Vec, while processing we haven't actually joined the words as earlier we had done, so that to combine it as a whole sentence. In the Word2Vec we have left it as an array only. So now when it is performing when it is actually converting, now when we are doing this, we are converting the X data frame to an X array. So because the Word2Vec library needs to accept it as an array, and the outermost element, outermost object is an array. Inside that also there is an array of every column actually has its own array, so it's a nested array. And actually inside the array, it's an array, but actually it's taking as a list in Python. And I actually tried it to even convert the internal array into a list, internal listing into an array using an np.array, but while processing it was giving an error, so better to leave it as a list only. What I mean to say is that we had a X data frame, which is this. Inside the X data frame, the reviews have been broken on the basis of the words into an array inside each column, inside each cell, data frame element inside the review column. So it's not actually a complete sentence. It has been broken into an array with array elements as each word. Now we need to convert that data frame of one column only. This actually data frame is a one column data frame, so we need to convert it into an array. For this we have used the np.array, and inside the np.array these things are stored as a list. Each of the column, in each of the row value is stored as a list, because the row is containing an actual array actually, but it has been stored as a list. Again and again I am repeating because this may be confusing. So you can see that for an instance the X array, which has a like each sentence broken down into an array of words. So the first instance of that X array means the first actually review has been broken into words which has a length of 168, means 168 elements or 168 words are there in that. Now using the X array we are building the vocabulary, and then we are training the model using some default settings like X array is there. We give total examples as this thing and epochs as model count. These are mostly default settings. Now where if we want to find a word similar to this word fairly, it's giving this as suspense storyline. These kind of words are having the most similarity to that. Okay, so this thing is not very much important. If you see this, if you want to get a vector information about the vector of a word itself, you can use this. This is a review column. Now this review column has the first row. In that first row also we had an element actually inside that. Each word had was an array element, so we need to refer it by the array number. So it's having this. Now the word has been converted into a vector, and this it's having this vector elements. Length of the model dot wv means the number of vectors it's having. Okay, so the number of values inside a vector you can find by this. This is the value for the vector array of the first word inside the first review row. So the length you can see 100 means 100 values are there. Now this thing is an important. What we will be doing inside the Word2Vec to calculate the machine learning algorithm for using Word2Vec, an issue will be there that for we are actually having 3 level of nesting inside the array over here, and the machine learning algorithm actually accepts a 2-dimensional array. Why it's having a 3-dimensional over here is that first level of dimensionality is the number of rows which is there inside the data frame, and the second level of is the number of elements which are present as number of words which are present as elements inside each of the review row inside the data frame or inside the array. Like since every review has been split in on the basis of space, so it has created that many number of elements as there are words. And inside the words, the word has also been broken into a vector of 100 dimensional 100 100 values. So there's a array inside an array inside an array. What we can do to eliminate one of the arrays and store the meaningfulness of that is that we can actually combine the corresponding values of the vectors of the each of the word inside one record. Since for an instance, we saw that inside the first record we are having 168 words. Now 168 words each will be having a array of 100 elements only, right? So what we can say that for each of the corresponding 100 elements we can take the mean out of the 168 elements of those rows, elements of that particular row. Like each of the word is having its own 100 elements, so we can take the mean of the corresponding 100 elements of the vector, so that for each corresponding record we get a vector of 100 elements. So in that ways we can get a two-dimensional array. The first means one dimension will be of the number of rows, and one dimension will be a vector of 100 elements in that row. Right, I think I'll try to explain it more better. Just see, valid tokens, the model dot mv dot token. For you need to see this. We have first taken the zeroth row of the review column. So in that now we are going inside that and considering the one of the model token. What I mean to say is that okay. Over here what we are doing is that another thing we need to take care is that if suppose, as we said, that there are two cases where we have only a single usage of the word in a whole corpus. We have not taken those into consideration because we kept the minimum number of times the words to be appearing in the corpus to be 2 for being taken into the vector as the vector. So what we are doing here is that we are eliminating the cases of those tokens which are not having the vector representation in our function. We have not taken the vector representation of that while building the vector embedding model. So over here we are taking only those tokens which are there in model.mv, like those which are not there in the vocabulary, those are not going inside this array. And there will also be cases when there will not be a single token inside the inside the review. There will also be cases where there will not be a single valid token inside the review because someone has put some gibberish which has been appeared only one time in the whole corpus. So to eliminate the cases where we are getting an empty array, for that case we will be taking np zeros, like it will be a single vector, it will be a vector in which all the values for that will be 0. So over here we have print the, and actually uh, uh, here we are performing that step which we were saying over there, that if there is a like we are taking the corresponding means of the 100 corresponding 100 tokens, corresponding 100 values of the vector for each of the word in the particular record. So if there is a word, if that word is having a valid embedding, then it is considered Otherwise, if there is a case that there is no valid token, there is no valid token and it's an empty array, then we are taking np dot zeros, means it will be generating a vector of 0 and then taking a mean of that. Okay, so this is a training data and you can see these rows are actually jumbled over here. This is the same only, nothing is this we have done same for extrain. Okay, so that one actually I did for the complete x, but it's not required. We need to do it for the only for x train only, because we will be performing the analysis for x train for training. So, and we'll be doing for x test also, but for x test we will be testing that data, so and it's better if we do a separate data frame for that. So x test mean embeddings as x, this is the actually x train mean embeddings. And again we are doing the same algorithms over there as we did, and you can see this has come 0.67. I think it was something 0.64 earlier for Gaussian mean, Gaussian what we say, just a second, Gaussian naive bias, yes. And then for random forest we are getting 0.74 only, so not much difference. We can see the what we got the key insights. For when we convert sentences into a vector token by token using model Word2Vec, we get an array of vector for each word. Our token are also processed as an array, and our sentence in the data set is processed as an array. We are getting three dimensional arrays. Since ML algorithms need to do two arrays for training, we need to perform word wise or column wise means we should, for a corresponding column of the um, same review, we will be getting a set of vectors values, because there will be multiple words in the same review. So we need to get a mean of those, so that we get a corresponding vector, such that we assume that it will be a vector corresponding to a single word review. We are converting the multiple word reviews into a single word review, if we can visualize it in that way, by using 100 value vectors, and then using that in our training. We need to set a minimum count of 2 or more. If we set a minimum count of 2 or more while getting Word2Vec model, we need to take care of the exception of the keys not present in the model vocabulary. Actually, it's vocabulary. While iterating and passing the corpus for or putting the token, we also need to take care of the edge cases where any tokens in the sentence don't match the model vocabulary. Means if the sentence is completely gibberish, then we need to, then that vector will be actually empty, so we need to convert that into a vector of 100 length with zeros, 100 zeros in that. And then the inference is there. A WAG of words and TF-IDF also had a similar score for random forest. In fact, no, this is not actually true. It performed similar only. We need to we should change this. It performed similar only. Similar for naive bias, yes. So this thing is complete. I hope you got some value. If you have some questions, then you can ask me. My contact detail will be given in the description of this video, and if you found some value or if you have some doubts, you can comment, or if some error is there in this video, also you can comment or contact me using the description. The relevant links will be given over there itself. Thank you.